believe so. Yeah. Hello, everyone. Welcome back to our series of reproducibility and open research talks. Today, I'm pleased to invite Dr. Thomas Klebel to present his systematic review on the academic impact of open science. Just to briefly introduce Thomas, he's a member of the Open and Reproducible Research Group and a senior researcher at Knowles Center. Is particularly interested in investigating unintended consequences of current implementations of open research and ways of improving the reproducibility of research findings, as well as avenues for sustainable business models around open research infrastructure. He's focusing on quantitative methods of inquiry and also interested in causal modeling and ways of improving research practice. Thomas has got his his PhD in sociology and holds a degree in music performance as well. I'm going to share links to his ORCID and LinkedIn profiles. And as I mentioned at the beginning, this talk will be about findings from the systematic review Thomas has conducted with his colleagues on the academic impact of open science. So basically, they looked into 489 studies and I found something interesting, which I'm eager to listen to. So, Thomas, you could share your slides now and move to your presentation.
Thanks, Shafak. And I'm very happy for the invitation and to be able to share some of our research which we've conducted over the last years with all of you. So as Shafak already introduced, the talk will be about the academic impact of open science. And before we dive into that, I'll just give you some brief background on the project because it's informative for the context and the perspective that we've taken.
You're muted. Let me unmute you. Sorry.
Oh, sorry, that must have happened. Sorry. So we conducted the research within the Pathos project, which is now drawing to a close. So it was a 3-year Horizon Europe project that's going to wrap up in August. And it was concerned with this question of which pathways towards impact open science has. And to that end, we conducted various strands of research, some more formal research into frameworks on these open science impact pathways, also on cost-benefit analysis for open science. We also tried to develop a handbook for open science indicators that should give researchers so-called recipes which they can use to investigate the impact of open science. And the thing that I'll be talking about today is the literature review on the open science impacts. So we conducted one on the academic impacts of open science, which I'll be talking about, but there are also 2 complementary reviews, one on the societal impact and one on the economic impact. So if we start conceptualizing the academic impact of open science, there are obviously 2 important terms here that I want to clarify before we can get to the actual results. And these are academic impact on the one side and open science on the other. And many of you will be familiar with open science and its many variants. What's important for me, just as a general framing, is that open science can be understood as both a bunch of practices and principles as well. And so there are many different ways of defining what open science is. They might have ups and downsides. Here I'm using the UNESCO recommendation one that just nicely maps the different aspects here. In green on the left side, you can see the more commonly known practices such as open scientific publications, open research data, open code, and so on. And this is underpinned by open science infrastructures that enable those. But we also have open engagement with societal actors and potentially also an open dialogue with other knowledge systems. And these practices have certain underlying principles, such as quality and integrity, collective benefit, equity and fairness, and so on. And these are really, let's say, crucial to how open science has developed. So as an example, the Budapest Open Access Declaration from over 20 years ago, which was one of the sparking moments of the open access movement, really had very hopeful and strong language that opening up research to general audiences via the internet would bring humanity together in this shared quest for knowledge. And today we'll hear a little bit more about to which extent that's actually happening. Moving on to the question of impact and what academic impact is. There are multiple ways of approaching this. One would be to look at the handbook that we've developed, where you can see very specific indicators that you can use to look at academic impact. For our study, we started out with a list based on prior research and our general knowledge of the topic that we then expanded based on what we found. And here we looked into citations. Citations are often seen as a very direct and prominent indicator of impact, and as such, they're a little more concrete than the other aspects, but we felt that it's still important to include it. But we looked also at quality, efficiency and productivity, equity, diversity, and inclusion, and then a few further aspects of academic impact, such as reuse, reproducibility, novelty, ethics and integrity, trust. And one of the key questions, of course, is how to link these open science activities towards the impacts. And one way that we've been conducting this in the project is via these impact pathways. And we're not going to dive into this diagram in detail. It's just to illustrate the logic and the thinking. So we start on the left side with some activity, here with citizen science interventions. And then we get some very concrete outputs of those. For example, the number of people participating in those citizen science activities. And from this, we can then see various direct outcomes. This case, for example, quality or novelty, which then leads to further short-term and long-term impacts. And from this, we can already see that this pathway from a certain activity towards long-term impact can become quite complex and difficult to trace to a certain extent. And part of that is that to be able to assess the academic impact of certain interventions, we need to be able to causally link these, because there might be many different factors responsible. But for us to make a claim that something is actually causally leading to a certain impact, we need adequate methods. And in the project, together with my colleague Vincent Trach, we wrote sort of introduction to one way of achieving that with structural causal models, where we formally introduce structural causal models. So this is still intended as a quite approachable summary of the existing literature on this, and then develop a case study, an example within the realm of open science, for which we simulate data to showcase then how this approach works. And we're not going to turn today's talk into a statistics lecture, but I find it still important to have some basic understanding of this framework, just as a general tool to think about causal relationships. So there are various things for which we might need to look out when we try to attribute a certain impact to a certain initial intervention. And one of them is what we typically would call confounding, which is quite well known, I'd say. Let's say we're interested in the effect of open access publishing on citations. This has been a quite prominent topic in the literature, and we'll talk more about it later. But there might be other confounding factors that explain any relationship that we can find in the empirical world. So, for example, it could be that journal reputation, not simply as the journal impact factor, but just more broadly, the reputation of certain journals has an effect on whether the journals are open access, but also has an effect on citations. And this could potentially explain any link that we see between open access and citations. And then for this reason, we wouldn't have an impact of open access on citations. More about this a little later, though. And I also have a second example that shows a potentially counterintuitive finding. So here we assume we're interested in the effect of open data on reproducibility. And we could claim that rigor, scientific rigor, both affects open data and reproducibility. We might further assume that whether a single study gets published might also be dependent on rigor. Obviously, more rigorous studies would hopefully be published more often, but also potentially be dependent on open data, because certain journals increasingly have mandates to open up your data, and if you're not willing to share your data, you might not be able to publish in some. And then depending on how these arrows align in terms of the strength of their effects and so on, it could be the case that in the published literature, if we only look at what's published, and that's what we typically do in scientometrics research, looking at OpenAlex or Web of Science and only analyzing the studies that we find there, then it could be the case that studies that share data openly are less reproducible. And I'm not going to dive into the details on this. You could find that in the accompanying paper. But what I want to highlight with this is that we need adequate methods for assessing causality in order to build this sound evidence for the impact of open science. So how does open science create academic impact? To shed some light on this, we conducted a scoping review where we included in the end 485 studies. So we started out with a very large number of studies and then went from title screening to abstract screening, looking at the full texts and assessing whether the studies that we were looking at really included any empirical evidence on the academic impact of open science. And that was really the main research question, to map out the existing evidence on this topic. We then also looked at further secondary research questions in terms of whether the impact that we found was positive or negative, direct or indirect, and what kinds of mechanisms produce these impacts. If we take a high-level view of the included studies, we can see that almost half of them were related to open access publishing, so quite a large share, followed by citizen science with about a quarter, and then 67 studies focused on open and fair data, various ways of sharing your data. And then we had further categories, so open evaluation, which mostly is open peer review, various forms, so open identities or open reports, open methods, open code, and also just studies that looked at open science in broader terms and very generally. This is looking at the types of open science. And then if we look now at the types of impact that we found, the most common one that was observable in the included studies was on citations. So this is a very common topic in the literature, then followed by quality and efficiency and productivity. And then we have a small drop-off, and again, a couple of other impacts of open science on academia. And we'll go through examples of those in detail in a minute. Before we do that, just a brief look at the disciplinary coverage. So we can see that the majority of studies investigated the impact of open science within the natural sciences and within medical and health sciences. And we also have a breakdown in the paper that you can see here on the specific fields. And our inclusion criteria were that we started with the year 2000, and you can see that in the first 5 years, there were only very few entries that looked at aspects that were relevant to our question, but then the literature started to increase with quite a substantial increase around 2020. So for our main findings, and I'll go step by step through these and try to provide a few examples. So the biggest category of open science impacts, of academic impacts of open science, related to citations, as I said. And here we found small to moderate increases in citations from open access, from open and fair data, and open evaluation. So this was always, in open access, it's clear that this concerns articles that are published open access or not, and they tend to have slightly higher citations, and I'll get into that in a little bit in more detail. Then for open and fair data, it would be that the publications associated with the data sets receive more citations. And in open evaluation, it would be that articles that have been reviewed where the reviewers disclose their identities might have small to moderate increases in the citations. However, there were unclear effects from open code and no effect from open science badges on citations. So open science badges are these emblems that some articles might get at certain journals for different open science practices, such as sharing data openly or others. In terms of quality, the studies we found reported neutral to moderately positive effects from open peer review on the quality of the peer reviews themselves, but there was conflicting evidence from open access towards the quality of articles, and citizen science had a neutral effect on the quality of the collected data given sufficient training, both of which we'll talk more about in a couple of minutes. In terms of efficiency and productivity, we found that the studies reported generally positive effects from citizen science, from open access publishing, and from open science in general, speeding up data collection and communication, broadly speaking. There were unclear effects of open evaluation, of open peer review on efficiency, with a small tendency for longer reviews, so that reviews took longer when people were asked to share their identities. And there's also a potentially negative effect of predatory publishing, which is linked to open access publishing, where authors have to spend more time dealing with spam emails. In terms of equity, diversity, and inclusion, open access leads to more diverse citations and also to more international collaboration. But on the other side, there is a threat for marginalization of those with fewer resources, both in open access and the article processing charge-based model there, but also in open and fair data, where lots of resources are necessary to be able to really benefit from data that's being shared openly. And also citizen science activities are primarily focused in the global north and therefore benefit only certain types of research and certain types of actors. In terms of reuse, this is a quite direct link. So we found a positive effect of open and fair data on the reuse of that data, which is quite direct and quite obvious in some sense. In terms of reproducibility, we found positive effects of pre-registration and registered reports on certain parts that are associated with reproducibility, but interestingly, no specific effects of, or no clear effects of open and fair data or open methods on reproducibility. So studies looking at whether articles that share data are easy to reproduce in general didn't find a generally positive effect there. In terms of novelty, there is a study that looked into the kind of potential long-term effects, claiming that there are certain short-term costs associated with open science practices, but that in the long term, such practices as open sharing of materials and larger sample sizes and other aspects lead to a higher rate of true discoveries. In terms of ethics and integrity, there was an unclear impact of open regulation on the integrity of the reviews themselves. So in terms of, let's say, how well-mannered people write the review and other aspects related to this. Open and fair data has a certain risk of re-identifying participants that one needs to look out for if sharing data sets. And finally, on trust, there were a couple of studies reporting on positive effects of open science badges on the trust in the results by scientists themselves. And next, I'd look a little bit deeper into the topic of the open access citation advantage. So that's quite a well-discussed topic in the literature. If we look at the studies and the overview that we had from before, we can see that we had 233 studies related to open access and 198 related to citations. And of those, in overall, 160 studies were directly concerned with the effect of open access on citations. And this open access citation advantage is simply a claim, let's keep it to still claim, that articles that are published via the open access model receive more citations. And there has been a lot of research on this question. And the key question here from our perspective in our review was what the specific effect of the openness on impact is. So we didn't look at, and we weren't interested in whether articles that are published via open access in general do have some impact, but we were looking for evidence what the openness changes in a sense. So in a causal language, what difference does it make that a given article is open access to the citations it reaches? And this is, again, a case where we need to be considerate of potential causal pathways, as there are a couple of potential biases in assessing citations. So a first one is the so-called self-selection bias. That's all of these are there are certain studies that find evidence for them or against them. So there's quite a lot of debate about them, but just listing potential biases that we need to look out for when conducting appropriate studies here. And the self-selection bias would be that researchers strategically choose which articles to publish open access. So in certain journals, it's possible to publish closed access via the normal route, or to pay a so-called article processing charge, and then the article becomes open access. And the argument would be that researchers might choose their better articles to be open access to maximize the reach, and therefore this might be a cause of higher citations among these open access articles. There might also be an early view bias that preprints leads to kind of obviously preprints lead to the article being available to the audience earlier, and since there's a time lag between the publication date and the time citations usually accrue, it might be that this kind of shifts the window, so to speak, forward. And if we then compare articles that are published in a given year, we might not be comparing like with like. That's the argument here. And this again might bias the number of citations we receive. Research funding might also introduce a certain bias because funded research has had some peer review before. It might, for this reason, be of higher quality, but also funded research tends to have mandates for open science practices, open access specifically, and therefore there might be a relationship there. There might also be a case where journal prestige is related to both of them. This is actually quite a common topic. So there are sometimes new journals that are completely following just the open access route via gold open access. So authors have to pay an article processing charge. And some studies in our sample then compared those newly established journals with very reputable journals in the field that have been around for decades, and then conclude that open access seems to lead to lower citations. But I would posit that this is, of course, more related to the journals themselves and less to whether they're open access or not. And there might be further factors, such as the missing use of an appropriate control group. Overall, from this, we can conclude that there is evidently a lack of a systematic account of these causal pathways related to the open access citation advantage. Some studies mention a few of those biases, some very few of them most, and some don't mention any of those. And so the overall assessment would be that very few studies actually have a robust design that would allow them to make a causal claim about the effect of openness of open access publishing on the citations. On the topic specifically, there was also a previous review by Langham and Patro et al. On the question whether an open access citation advantage exists or not. And they found, similarly to what we found, that there is a great variety of how people assess citations and assess open access status. And for that reason, it's also difficult to make sense of the literature to a certain extent, and to compare the different articles. They found that a relative majority, so close to 50% of the studies included in their assessment report finding an open access citation advantage. But they also concluded that only 3 out of the 134 studies that they included had a low risk of bias, which is quite astounding and points to the need for reporting guidelines for scientometric research. Broadly speaking, and this is evident from our dive into the literature as well, that there are many different ways. And as I said, it's hard to compare what's what. Langham Patro et al. Also investigated whether differences exist between the various pathways towards open access. So I already explained briefly gold open access, which is journals where authors have to pay this article processing charge, and then all the articles are openly available. Hybrid is what I explained before, conventional journals offering you the option to publish open access, and then you pay this article processing charge. And green is simply that authors deposit their manuscripts, either the initial manuscript or the accepted manuscript, in a repository, and the article therefore is open access. And in their study, they found no statistically significant difference between those. But in our view, that is also partly due to a questionable decision to merge the hybrid and gold categories, which I'll explain just now. So to sum up our findings, there seems to be a positive effect of open access on citations, but it's not very large. So studies that have a robust design generally tend to find small to moderate increases in citations. We haven't quantified this. This wasn't the initial aim of our study, and therefore not possible after the fact. But from looking at a couple of those, this would be something between, let's say, 5, 10, maybe 15% increases in citations. Whereas some studies that didn't have a very strong design in terms of separating the different effects, these studies tend to have very high numbers, some of them. Importantly, we also found, just going through the literature, going through the studies, that there tend to be some differences in the variants of open access. So green and hybrid open access tend to have higher citations than closed access, whereas gold open access tends to have fewer citations than closed access. But that's all of these are potentially due to some of the biases that I have introduced before. This is just to note here. Looking beyond the open access citation advantage, just to broaden out the findings on the largest category, open access, a little bit. What I find to be a very important aspect is this finding by Huang and colleagues that open access research outputs tend to receive more diverse citations. That goes hand in hand with the initial goals of open science that I initially discussed. And they found increased diversity in terms of institutions, countries, regions, and fields of research, citing certain pieces of research, comparing open and closed. But there's also a certain threat to equity, at least in how open access publishing is currently being implemented. A study of Smith and colleagues found lower geographic diversity of authors among articles published via APC-based open access. And in a study together with my colleague Tony Rosellauer, we also showed that APCs are tied to institutional resources, so researchers that are employed at institutions that have higher resources tend to publish APC-based open access more often, and also pay higher APCs. And this is a problem to a certain extent, because as before we might have had a barrier to who could read articles, now there might be a barrier to who is able to contribute to the literature, and that's of course somewhat against the initial aims of open science and open access. And there are also certain other aspects, particularly related to in the COVID-19 crisis, related to preprints. We see a couple of studies that showed increased efficiency there, but also the emergence of predatory publishing, which on the broader scale doesn't have an impact on the literature itself, because these articles tend to be not highly cited. Going ahead to the second largest category, I'd like to dive a little into citizen science, and that's an area where we could literally go for a dive, so to speak. Citizen science, just broadly speaking, means involving citizens in the research process, and there are various ways of doing that. They range from just including citizens into the data collection up towards really collaborative science, where research is conducted almost on an equal basis between scientists and researchers. And in the studies that we included in our review that showed evidence for an impact, most of them were related to biodiversity and wildlife monitoring, so monitoring of certain animals like bees or birds, and general marine environments of fish and other species. In terms of the impacts that these studies report on, one line that really goes through many of them is that citizen science projects and citizen science activities are able to increase the temporal and spatial scales of monitoring activities. That's also then quite directly tied to moderate to substantial cost savings. So there might be an initial cost in setting up such a project, but after that, if you're able to include citizens in your data collection, and this is how most of these studies worked, so they included citizen scientists into the data collection process. This makes it much easier, of course, to survey large pieces of land for certain species than if just researchers were doing it. But some of the studies that we found also report on citizen science projects having a positive impact on discoveries and enabling novel perspective and novel discoveries, because the citizens themselves have a very diverse background which they bring to the table. A large discussion in this literature has been, at least over the last years, about the quality of citizen-generated data. And initially, this was a larger concern, with more criticism towards this question. In the more current studies, we sum up the the findings of those studies that citizen science projects can generate data of sufficient quality for monitoring activities. But in this sentence, sufficient is doing quite a bit of work. And that's partly on purpose because there is no agreed definition on what sufficient means. And so this potentially might become a moving goalpost when researchers conduct an activity, conduct such a program where they bring citizens in and then try to assess whether the data are sufficient for their specific purposes. A few of those studies have pre-registered what they set out to do. And since there is no agreement on the specific definitions, it might be that there is a small change in what they would say, whether that's appropriate or not. So there might be a certain bias in the published literature. There might also be a certain publication bias because of the many citizen science projects, not all of them, and in fact, there's, I think 20 to 30% only have publications associated to them, and not all of them might have the goal of producing publications, but it might still be the case that activities that are less successful simply are not being published about. In terms of important factors, key here are training and protocols, and in that sense, citizen science is like any other method that the study design is important. And if there's an appropriate study design for a given task, then citizen science data is very usable and comparable to scientist-generated data. Coming to a close, slowly and summing up the findings, first starting with the summary of what we would say are methodological concerns. What we found predominantly in our screening phase was that there are many studies looking into the uptake of open science, but fewer ones looking into the specific impact. And of course, it's important to first start with looking at uptake, but if you're interested in what the actual impact of a certain activity is, it's not sufficient to just look whether people are doing it. We need to look at what this doing is changing then after the fact in the real world. There is also a potential streetlight effect in the sense that there are many studies on this so-called open access citation advantage, but maybe that's also partly because that's relatively easy to do. Maybe it's not easy to do it well, but on a surface level, it's easy to do. Just need to pick a few journals, download some data, and compare those. And so there are still remaining knowledge gaps on other areas. As I've outlined at the beginning, it's quite difficult to relate the different activities to then certain outcomes and specifically long-term impacts, because there's also a long time frame between those. And there's also a lack of standards for defining and measuring certain impacts of open science, some of which we've tried to address with the indicator handbook that we've developed. In terms of future directions, we would argue that there is a need for greater support for impact studies in general. A lot of policies building on open science, and so it's important that the specific impacts of these interventions are adequately assessed. I'd also argue that policymakers should really look at the existing evidence and potentially prioritize their activities accordingly. So borrowing from my colleague Nicolisa Cole from the societal impact study, there's a lot of evidence there that citizen science generates a lot of societal impact, but there's not much funding for it. And similarly, in the open science area on academia, there are areas where it would be important to have maybe more policy focus. One of which would be that I would argue some of the kind of further upshots of this research being that we found evidence for reuse, for example, from open research data. And for that reason, to enable a broader impact of open science in general, I'd argue that it's important that we as researchers and other stakeholders involved in the research enterprise really support researchers in pushing more diverse types of research outputs, not only focusing on academic publications, but sharing the code and sharing the data to enable others to learn from what they did. And in that sense, also support the reform of research assessment in a broader sense. 3 take-home messages to maybe also jumpstart the discussion. From our study, we can conclude that open science has generally a positive academic impact on the broader scale, but we need to be mindful of potential negative side effects. And all in all, we also need better methods to assess the open science impact on academia in the future. Thank you very much.
Thank you, Thomas. That was very informative and insightful, and nicely put together slides with the color coding. Helps you, understand the data better. I am looking at our chat function and checking with our participants if they would like to ask any. So there was a comment from Kate, for example, that the better articles might be subject to public access mandates by funders. That's maybe another source of selection bias, she believes. Kate, let us know if you would like to expand on that. Okay. Any questions, anyone? Right. So I'll go first with mine. So if you had to prioritize one area for future empirical research into the academic impact of open science practices, so what would it be and why?
So I think I'd prioritize 2. One would be open and fair data, because I would say this is an important practice because it really enables others to build on your research, and that's kind of one of the underlying, at least assumed norms and principles of open science, that you are maybe less interested in your own career, but in kind of generating more knowledge over the long term. And for that reason, a better understanding on where, how, and why open data generates or doesn't generate longer impact, I think would be important. For example, this link to reproducibility and potentially other practices such as data management plans, where there's a lot of, let's say, policy focus, but maybe not so much empirical evidence of what it actually brings in terms of long-term impacts. For example, in terms of reproducibility, this would definitely be one. And the other aspect that I think is still important, because it has received a lot of policy attention, is open access, but not to focus on the citation advantage itself, but more on these other aspects that Huang and colleagues looked at in terms of diversity and potentially other benefits in more domains that are maybe harder to assess and estimate, but still very important to the underlying goals and aims of open science.
Thank you. Meanwhile, there is a question from Kate in the chat function, which says that really interesting talk. So the question is, the context Kate is coming from, which is public health in the United States, means that the terminology citizen science is encumbered with some concerns that as a term, it potentially excludes people who are not citizens. So did you consider, she's asking if you considered whether using other terms like public science or community-based participatory research or community engaged research, not that those are all the same thing exactly, but she believes that she can imagine them being used by people who are practicing open science if we define open science broadly. So what is your view on that?
Thank you for the question, and that's a very important view. It's not one that we encountered, to be honest, in doing our research. So we followed some of the policy documents on open science that are from the European Union, basically also to look at the various pillars of open science and to settle on what we wanted to look at. And there the term citizen science was used, but I agree that kind of public science or community-based or participatory research might be a more inclusive term. So yes, I would agree that it's important to think about that. It also aligns with another terminology debate, let's say, in this area, because I'm talking all the time about open science, but science might also exclude areas such as the humanities or other aspects. So there might also be an argument for speaking of open research, broadly speaking. We've just stuck to the more conventional terms here, but these are important considerations. Yeah.
Thank you.
Can I ask you something? Hi, it was a great presentation and really interesting. I looked at your articles during the presentation. Why do you think, first of all, there are so few randomized trials? And then I see you didn't touch it all. I mean, I know very basic things about causal inference, but could it not be that some people who are very much aligned with some open science policies like pre-registration and so on have a direct interest in continuing to promote these policies and continuing to so like a form of conflict of interest, basically, so to speak, which could also in a way determine which journals are taking these journals. So I come from psychology. Okay, all the APS journals, American Psychological Society, have adopted badges. There was a trial, it showed badges didn't work. Everybody said, oh no, the trial was not well done. So this kind of more indirect influence on
thank you for the question. So the first question was why there are not more RCTs, you asked, right? Randomized controlled trials. I think part of that is that it's quite hard to do that. So interestingly, in another project, we are currently doing just that. So we have another project on reproducibility called Tier 2. And in one of the studies that I'm leading there, we are interested in a very simple intervention that would hopefully boost the rate of authors actually sharing their data. And when we tried to start this, many of the publishers were interested in participating, and many participated with us as well in the design. But then when it comes to actually implementing it, that's much harder. So in the end, we are able to run the study, but still it's very hard to recruit publishers because there's no direct and specific benefit for them in a monetary sense, let's say. And therefore it's hard to justify internally, even if you have people that are interested in this and want to do it at the publisher. They sometimes have a hard time justifying against management or other aspects of why they or anyone else in the organization should spend some time figuring this out, because there's always some overhead on running those. In terms of the conflict of interest, I would tend to agree that there might be a certain kind of blind spot in the community, in the science studies community, because some actors have a vested interest in the tools and approaches they are pushing. You can see that also again with the example of reproducibility, that there is also quite a debate about what reproducibility is or should be, and why it should be or shouldn't be important, and so on, and very different views on that. So yes, there might be even more publication bias than what I have tried to outline. Because in the citizen science example, it was relatively obvious, I think, at least to me, that there is some potential conflict of interest if you have people setting up an initiative and then writing a publication about it. It would be better if there was more independent assessment and maybe some guidelines on what constitutes, let's say, sufficient data quality. But then again, also data doesn't have to be always of exactly the same quality in the citizen science project. So maybe what's useful for a certain initiative might be not useful for another. So there's also fine to have some difference there, of course, but yes, there's definitely some potential for conflict of interest.
Thanks.
Thank you both. Yeah, and there was a further comment from Kate, as she's a librarian. So next time you use this research, I guess, which refers to citizen community-based participatory research, she suggests truncating it early enough to capture citizen science too, because the stemming lemmatization, which is a new term to me, in Scopus and Web of Science is not aggressive enough to do it for you. So something to consider. Thank you. That's very helpful. And Kate is asking another question, if you could provide a little more detail about the confidence assessment. It looks like the paper does not mention a particular risk of bias assessment instrument or is suited for instruments. What do you think?
Yes, so we didn't conduct a systematic review in the narrow sense, but a scoping review, and we did do some basic confidence assessment, but we didn't formalize it because we were looking at such a big variety of studies. That's why we felt we couldn't do it kind of in a formal sense, but when going through the studies, we tried to note down any concerns we had on the design of the specific studies or on the results. And then we used this information in the write-up. Basically, we didn't want to highlight any studies in our write-up that we didn't feel confident about. And that has been kind of the rule, how we presented the evidence.
Okay, thank you, Kate. I hope it addresses your question, but let us know. Let us know otherwise. Just to summarize, and I really love the slide with color coding. So, was there anything that was striking as particularly weak as academic impact to you, Thomas?
What do you mean in terms of particularly weak? So kind of weak evidence or weak impact?
Weak impact as a practice, yeah.
That's a good question. I might need to look at my color coding again. So what kind of what struck me more in terms of not so much in terms of weak impact, but maybe weak evidence was really kind of the patchiness in some areas. And one thing that came up very late in our process was this example of data management plans, where there is a lot of policy focus behind it. In Horizon Europe, they're mandatory and so on. But in one of the studies that we found, one of the reviewers also mentioned, and this is a case where I really loved having open peer review, that it's quite striking that a systematic assessment this other study did on data management plans and other practices was that there were only few studies looking at this until now. So there are really some areas where there's a lot of policy focus, but not much evidence as to the positive or potential negative effects. And this mismatch, to a certain extent, I found quite interesting.
Okay, that's good to know. Thank you. I believe Kate is typing anything, something. So I'll probably give it a minute or so. Yeah, there is something. So Kate is following up. She's curious about whether citation chaining results in the inclusion of additional studies after traditional search and screening process. But looking at the Prisma flowchart and the paper, it's not clear if any of the reports assessed for eligibility as part of the citation chaining process ended up being included. And she's thanking you for being so patient and answering all her questions.
Thanks for the question, and that's a very good question where I'll have to get back to the journal because unfortunately the Prisma chart that's published seems to be incorrect. And I just discovered that I think yesterday or the day before when trying to show someone the Prism chart as an example. So yes, we did include studies from the snowball search, from the citation chaining, as you call it, but unfortunately, in the published manuscript, this is not included. So we did just for other people that might have not looked into the Prism chart so deeply, we did first a systematic search of the literature and ended up with, I think, around 300 studies, and then we used those as a set to look at further articles that cite those articles or are cited by them, to discover more articles relevant that we missed in our initial search. And then we screened those following the same protocol and included them as well in the data extraction and analysis. And by the way, just as a comment there, because we felt this was quite, to a certain extent, interesting and innovative as well, all the code to do this and all the data is publicly available. So if you're interested in looking at how we conducted those steps, then you can follow the paper and find all the code and data there.
Thank you. I will add all the available information to the recording on which I'm going to share on YouTube. Thanks very much. That was very informative, and thank you for your thorough explanations as well and being so patient with us. It's been a pleasure to host you, and I'm looking forward to sharing this on YouTube. Thank you, everyone.
Thank you as well.
Thank you very much for interesting speech.
And thank you for the interesting questions.
Okay. Stop and recording.